current session, we have the session on fault detection and diagnosis of motors used in electric vehicles. So, myself, Dr. Giridhar from Department of Electrical Engineering. So, I will try to discuss, focus on mainly on the detection aspects, some of the diagnosis aspect. So, Professor Ilamparthi SAR is covering so many aspects, different algorithms for the diagnosis of the uh, machines for the electric vehicle applications also. So we have as a widely mechanical faults, electrical faults, demagnetization faults, electromechanical coupling faults. So we will try to focus on like mechanical faults like eccentricity faults, uh, bearing problems. So those aspects will come in mechanical faults. So when it comes to electrical faults, we have interturn short circuit, face to face short circuit, face to ground short circuit. So so it may be caused by insulation stress behavior, thereby the failures due to the transient over voltages switching aspects, especially when we are going for PWM applications. So if there is any excessive temperature, hot spot, everything, that may cause the problems, interturn faults, and mechanical vibrations. Even frequently, when we are starting and stopping the uh, machines, that may also cause this type of problems, overload aspects like that. So if you could observe the interturn short circuit, so usually in permanent magnet synchronous motors, this type of faults will be regularly it will be observed. So the causes will be of interturn insulation when it is subjected to transient over voltages while during starting conditions. Also stator winding temperature. So in that way, if it is very high, it will may causes interturn insulation failures. Stator winding coil friction when there is a damage between due to vibrations. So even in under the harsh environments, whenever there is a harsh environments, humid and high temperature environments when the machines are operating, so this kind of may happens. Also, this turn to turn short circuit faults in stator winding causes the asymmetry in the three phase stator current also. So another one like phase to phase, phase to ground short circuit faults. So if there is any, uh, there could be observation like sudden change in current may happens while during some motor operation. Sudden change in current may happens and with a very short durations. So those kinds may be referred to may be of related to phase also. So usually this will cause by broken insulation materials inside the motors or by the lapping of windings through non-conductive materials. So those could be the reasons where this kind of faults will be happening. So my aspect is one particular aspect where the switching aspects, the problems associated with that, I'll be focusing on. There could be a different uh, reasons, causes. So basically, if you could see the electrical assets for the transportation, electrification, they are mainly now relying on power electronics, in which they will improve these energy aspect, power dynamics, control aspect, and in that way it will makes the system's flexibility. So high electric field and temperature, when you are combining with larger converter or inverter frequency and switchings, like rate rises of these switchings, this will impact certainly the stress in the insulation system. So that affects the reliability of the machines. So usually this we can see voltage can reach levels like in terms of higher voltage levels like kilovolts, especially when we are going for the applications like electrical ships, aircrafts. So and this causes the stress behavior in the insulation, aging mechanisms. So mainly, if you could observe in the nowadays, we are going towards the silicon carbides. So those polytronic devices. So for PWM source inverters, when you are going for that pulse width modulation source inverters, for achieving high frequency, high voltage, and also fast rise of time time voltage impulses, when you are trying to go for like uh, like speed control with high speed control of and efficiently if we want to go. So we are trying to go for this silicon type of carbide type of devices, where this features it is having like high frequency switching, high voltage we can get, as well as fast rise in time. That is also impulses it will give for the applications like high speed trains and electric vehicles. When we are going for that, it is required. Even we are going towards the wide band gap devices also, so where it will have very high switching impulse voltages, so thereby we will be achieving very high speed control efficiently also. So those things, when it comes, what happens to the insulation aspect, insulation of the equipment aspect. So this that will creates the stress in the insulation. So thermal stress also will come into picture. So this will makes the insulation to deteriorate. And also what happens is, with this stress mechanism, gradually it will uh, gets into partial discharge inception voltages, like particular voltage levels. What happens is the partial discharges will be initiated. So these are all not completely bridging the insulation to ground, but partially it will be bridging the insulation. So these discharges gradually, once it is incepted for the particular voltage, then even it is a minor, gradually with respect to time the insulation will gets deteriorated. So thereby it will ultimately it will causes the breakdown of the insulation. So there will be there could be sometimes catastrophic failure of that machine also, because of these, due to these reasons also. So we may think it is minor, nothing problem, but at the when time comes, when its severity comes, what happens is it will gets a very high failure. So it is a personal, as a person problem, or with respect to the equipment problem, all will be taking place. So that's where the insulation of inverter fed motors, so uh, it uh, it has to be withstand very intensive stresses, and thermal stresses also it has to withstand. Even if you could see uh, in the uh, International Electrotechnical Commission IEC standards, they also mentioning like conventionally we are going for the AC sinusoidal, but now we are going towards the PWM switching aspects using such devices. So both sinusoidal as well as this repetitive impulse voltages has to be withstand. These machines has to be withstand both sinusoidal as well as repetitive impulse voltages. So also in the standards like partial discharge inception voltages for low voltage machines, they are giving for the standards. Even endurance tests to be conducted for medium voltage range of machines also. So such type of standards they are imposing, so that the machine will be effectively works continually long time with proper functioning of its life. So you can see stator winding insulation failures, drive side shaft bearing failures also will happens. Even the old machine which has been in service retrofitted with variable voltage and frequency for achieving the speed control and improve its efficiency, that sometimes we would have applied for designed for normal AC sinusoidal conditions, but once you are changing with different environment, so there may be failure of the machine also, because it is not designed for that. It has to be designed and it should be properly tested with that standards, and this uh, type of inception voltage levels, thermal stresses, endurance tests for different ratings of machines has to be conducted. Then only reliability will be achieved. So two level PWM, usually we are using in low voltage drives for machine voltages up to 690 VRMS line to line. Multi-level, even multi-level converters we are using for megavolt drives up to 11 kV like that. So in those voltage source converters, so which are rated for megawatt also, we have to take care of all the aspects like harmonics, interharmonics in the inverter output, and machine windings. They also increase machine stresses like electrical, thermal, mechanical effects also. So as we are going towards the variable speed drive applications for electric traction, rail and high speed rails, trains, and also electric vehicles, so where we are using induction and permanent magnets, where motors are used, and also other applications are we are using this. So the winding insulation will constantly subject to high transient electric fields, so that should be withstand by the insulation. So if not withstanded, what happens is partial discharges will take place. So you can see in the even ton to ton insulations with jump voltages, aging tests also to be performed. So typical some phase to phase voltage waveforms for a two level inverter. So UP is peak voltage at the motor terminal, U pk by pk, peak to peak voltage at fundamental frequency. So this is a phase to ground voltage waveform of 2-level voltage converter fed motor. So if it not withstanding, you can see that there is a some discharges will be happening. Even you can see in the switching aspect some discharges will be there. So once the partial discharge is initiated, then with respect to that switching, gradually it will get severe, and it's usually we will measure these discharges in terms of picocoulomb. So that also will increases gradually with the deterioration of the insulation also. So with respect to the frequency of that uh, pulses, you can see the discharges are occurring. So with more higher frequency, again higher, with respect to that you will be getting the discharges. Even in the, it is a normal discharge at the initial level, but what is happens is with respect to high frequency aspect also, you are going to get more discharges. So at a particular 1 kilohertz, so these are the various type of discharges usually occurs, like internally if the discharges occurs, it is like internal discharges. So if there is any manufacturing defects also, like some voids, cavities are there, you have designed for particular voltage level. Due to these switching aspects that cannot be withstand, and they will at that cavities, it is like air medium when compared to other insulation medium. So what happens is that stress at air medium will gets very higher level. So if it is like perpendicular interfaces, so it's like this will gets very heavily, because other is suppose E1 by E2 is epsilon R2 by epsilon R1. So epsilon R2 is 4, epsilon R1 is 1. So the stress at this air pocket medium is highly subjected to high stress. So thereby discharges happens. So in that way, gradually it will deteriorates again. Or even if there is any stress component that on the parallel to the surface, also surface of the insulation, we will be going to get surface discharges, like in the gaseous medium, in that corona discharges. Like that, uh, these stresses will have its own natural way of getting the discharges with respect to the AC stress. Even we can use this uh, data with respect to the AC stress, and we can diagnose its problem. So as sir has mentioned about the different AMML techniques, we can adopt with that data set, and having different patterns that is there with different defects, so we can able to identify what type of problem. In that way we can diagnose the systems. So we can use some of the techniques, detection techniques, like high frequency current transformers, even some antenna type of techniques also we can use. Also acoustic type of sensors also we can use for the detections. So you can see the PD pulse. So different frequencies, how it is. So you can see here, as I told, that different type of, based on the different type of defects also, the magnitude also it will depends. So corona discharge may have less magnitude. This surface discharge still higher magnitude, and internal discharge is still higher magnitudes. Based on the defects also it depends. So in that way we can have the uh, uh, with respect to the detection of these discharges, there could be some external noise also. So that noise with that discharges, so we should be able to separate it. So once we have separated, then we will get a much more easy way of diagnosis the problem, everything. So in that way, that detection, separation, and also um, recognizing the uh, what it is, and thereby we are able to identify. Like different statistical parameters we can use: time, frequency, entropy, and also professor was explaining about this principal component analysis, that also we can use for its uh, separation. So that's where here uh, recognition of this type of defects should be automatically done with the using the appropriate algorithms. So we can see as a different aspects: noise, partial discharge aspect, how it is, and if you are able to separate it. So even we can use statistical techniques, variable distributions. So for the partial discharge pulse magnitude and pulse shape. So based on that also we can get the extraction. So we can identify what type of faults based on these shape parameters of different type of variable distribution. So as sir was explaining about this variance, skewness, kurtosis, so this will, in the time domain analysis, it will helps in identifying the particular what could be the defect it could be. So in the some of the references they have done extensively and able to separate and recognize and identify the faults also, and able to show that so this type of particular fault is type of discharge is occurring, like that also they are able to recognize. So these uh, partial discharges, they are the localized electrical discharges which are partially bridging the insulation between the conductors. So these are localized stresses which will cause gradually, even if it the minor problem, gradually it will makes very severe problem. So if you could able to detect and able to uh, classify and able to localize, so that will be a best way for diagnosis. Even very big propulsion motors in ship industry or aircrafts, when we are seeing, so there with the big missions when they are using, so if you could able to do such kind of things, problems, so if you are able to detect by using sensors, minor problems, very minor problem, sensitivity should be very high, sensitivity should be high. In that way we will be able to detect at the earlier phase itself. So that aspects challenge is there. So how we can mm, have a design of the sensor particular very minor problem able to detect. And also signal to noise ratio, so that is a main problem nowadays, vibrations, everything coming. So how we will able to distinguish, how we will able to separate, sir was saying in the session. So that's the challenges, where how to separate it. So the disturbances are there, but you should have to get the correct problem, you have to able to get the able to take out the correct problem, that discharge. So how to do, so the sensor aspects also should be designed for the particular proper specification for that. So once it is done, then we can go for the whatever the data that is getting through the sensor, and able to do filtering of noise, everything. Then we can, with that signal processing, we can adopt these techniques also for classification. We can apply A and ML applications. So whatever the discussions we are doing with sir, so that effectively we can adopt, we can apply for this type of problems. So we can observe here, like there could be like the problem is this partial discharge. These partial discharges will have a different manifestations. So it can have emitting a light, so we can use optical techniques, optical sensors we can use. So wherever this aspect, if you could observe easily, these optical sensors we can easily keep. Or because of these discharges, these are all electrical discharges, whatever the discharge we are having with that insulation stress, electrical stress, and able to not withstanding, and it's getting the discharges, these are all electrical discharges. So as what we are seeing in the transmission lines, so at the tower structures at the end there could be sharp points. So during rainy seasons and all, the surrounding medium is ionized. If it is crosses the disruptive voltage level, you will be getting the corona discharges. So a glow discharges we can see, and like that the manifestations of these discharges, partial discharges, will have different, like with respect to the visibility of discharges, or having the hissing noise, and as well as it will creates the pressure waves. So these pressure waves, we can use some acoustic sensor which it can detect the these pressure waves by using piezoelectric sensors. So with that pressure waves, we can able to detect that. So using piezo acoustic sensors, we can detect. Even with these discharges will emit electromagnetic radiations. whatever the discharges, once it is partially discharges are coming, this, suppose if the supply is 50 heads, suppose, even in that case these discharges will have emit electromagnetic radiations. So these radiations can be picked up by placing the appropriate antenna like sensors. If you could place, it will picks up the electromagnetic radiations. So in that way, these discharges can be able to detect with the different type of manifestation it is having. From that, we can develop a different sensor, multi-sensor fusions techniques. We can have that, and we can use for our purpose, whichever is having very good signal to noise ratio and getting good detection, that we can adopt easily. Even in the chemical effects also, so these discharges may deteriorate, and it will causes the changes in the chemical of the changes of the polymer chain of the insulation and all. So in that way you can see, and also thermal effect like that. So in that way we can uh, design a different type of identification and detection techniques. Like one can be of electrical signals. Even we can use high frequency, because these are all of very high frequencies of megahertz to gigahertz range. So this frequency, as we are knowing that earlierly, even in the rainy seasons and all, nearby the power lines, communication lines will be going on. So these discharges once comes, these are all of megahertz or gigahertz range, so that will interfere the communication lines. So that's why earlier they are using telephones and all lines. So in the rainy season, this type of problems will come because of these interference effects. So likewise, this will have very high frequency discharges. So in that way we can develop a ultra high frequency techniques, sensors, to pick that signals. And if you could appropriately design such a way that particular bandwidth whatever it is having, if you could design, you will get good signal to noise ratio. Actually, this is these are all for partial discharge measurement, uh, state detection methods, so electrical detection methods. So the we'll be trying to set there as a standard. We'll be as use as a standard. Even non-contact type of sensor we'll develop. We'll try to see correlate with these standards. So suppose the discharges are coming, how these non-contact type sensors we developed, whatever developed, uh, whether it is showing or not. Suppose very low signals from the these standards we'll be getting, but sensor may not pick up, suppose. So we can say the sensor is having this much able to detect from this discharges onwards. It's not able to able to detect. So this acts as a standard, and even we can correlate with that. So how the, suppose acoustic sensor we have developed, UHF sensors with different bandwidths we are developed. So how it is giving. So in that way also, as a standards, we are using the conventional IEC standard. So this is about. So even we are developing high frequency current transformers. So how it is with respect to the IEC 60270 state detection methods, like it is a state detection current detection method. So these are the acoustic measurements where we can use uh, for the even some of the researchers, they are trying to use like in missions inside that with proper insulation and all, without affecting the windings, everything. They are using a number of acoustic sensors like that, and from that they are trying to uh, detect the fault, detect the problem, and able to localize also. If you could use the um, uh, like uh, time of arrival from uh, like based on the different sensors, so how it is. So some suppose for a particular sensor, if the defect is very near, it will gives very high magnitude when compared to others. So uh, in that way also we can try to detect where the particular position the problem is occurring. So you are able to detect and able to you should able to identify by means of diagnosis and localize also. So some of the optimization techniques also we can use for the improving accuracy also. So we'll be able to get, but if you are getting at random for even optimization techniques we can use, so that we'll be able to get accurately nearer to that where the problem is occurring. So these are UHF sensors. So type of PD, detection, frequency range. These are the parameters, radiation pattern, like that. So particular antenna type, different type of antenna designs, like narrow band, uh, wide band type of antennas also we can use. So it depends on applications, how we want to go for the designs. Sometimes even different other type of power equipments, they can place the drain valve of the, suppose the transformers drain valve sensor at that point, oil point, or they can use some dielectric windows. So dielectric windows, in that they will place these sensors and they will try to detect, rather than placing inside they will try to use that dielectric windows. So in that way also they are able to detect. So different parameters they are using for better picking up that signals, everything. You should have these parameters to meet. So typical uh, discharges. Uh, so this is the time domain signal. Other side is frequency, FFT. So what are the frequency components present? Suppose with respect to the severity, what happens is higher frequency bands also you may get. Suppose earlier um, inception level you may have till 1.8 or like that. Now if you could see at the higher voltage levels, the frequency is shifting to higher frequency also. So 2.2 gigahertz, like that it is shifting. So in that way also we can try to uh, uh, use this for the diagnosis. Like we can apply this AI techniques, where we will be able to identify this the at the inception level the problem. So when you are it is going towards the 2.2, so it's getting severity. So in that way also we can able to identify. So this typical continuous wavelet transform, you could see uh, you can able to distinguish uh, like low frequency components, high frequency components, like that also very easily we can able to get from this wavelet transform techniques also. So from that also, using that coefficients very well, uh, we can go further for the classification also using this data. So raw data one is there. So if you go towards this, the time at which that frequency components are occurring, like that. So you, in that way also it will give much more information for easy way of identification of that what type of fault type of problem it is. So corona will have different thing, surface discharge will have different thing. Like likewise, the internal discharge of this insulation will have a different thing. So in that way, you will be able to get that extracting that particular easily what it is occurring. So these are the for the acoustic sensors. When you are placing different sensors, even different UHF sensors, if you are placing, how I can do the localization aspect. Somewhere it is occurring where I have to how to localize. So I can use this type of multiple sensors. Even we can go with like multi-fusion sensor technique also. Like one particular sensor will give one very good patterns. Another uh, another type of sensor will give particular signatures very nicely. So like that, combining the features, what it is giving very good thing. If you could combine that, then easily we can able to identify the problem. So like combining the different aspects, morning also sir was explained, like you use this uh, current signature analysis, some other analysis. So if you could able to extract the different things, combining this, you could able to get very good the what real problem is. Even we can omit the noise here as well in that case with the use of this multi-fusion sensor techniques, if you could adopt. But everything we have to see the application where we are using, how the cost, how importance it is, those things and all we have to see properly. So different approaches we can go with the identification of the particular localized parameter. So these are the different time domain signals at a time we can get, and we will try to uh, do the arrival of that particular signals at particular positions. Based on that, we can try to adopt even optimization techniques to get accuracy, localized accuracy where it is occurring that problem. So in that way, we are able to detect and try to classify, as well as we are able to localize. Localize also we can by using the different sensors. Even nowadays, some other type of sensors, fiber Bragg grating sensors also they are using. So where the particular wavelength it will shows how the like suppose temperature of the coils, everything we want to know that. So if it crosses a particular temperature, so that it will shows high wavelength. In that way you can detect. So those type of but thing is in between the coil we have to insert. So as sir told, like if it is like invasive, like we are inserting, and properly it should be calibrated properly. Otherwise it is difficult. So calibration, packaging, installation, these aspects very finest they have to take care. Otherwise you won't get much the measurement aspects, and all we have to take care very well this. So while this coiling this we are inserting these sensors. So how we are doing packaging aspect, how we are able to embed, and also how installation, how it is. This matters a lot. So all these aspects are very important when such type of detection we want to do, and because we will be getting easily, that is the advantage. But thing is, proper properly we have to take care. Something miss remains problematic. Like so many precautions also they will be taking place while putting that sensors properly, some capillary and all that arrangements, everything, so that nothing will be affected for that electrically everything. So and it will tries to what happens is these fiber brag grating sensors can get the mechanical disturbances, that vibrations also it can get, and also temperature, that that also it can get, but we want to avoid this. So for that avoiding we have to use such arrangements, so that only temperature it is able to detect such type of things, and all we have to be take care very well the design when we are trying to do the detections by using sensors, all those kind of things. So this all things sir has explained clearly. These are different failures of induction motors and all. So you can see CSA cracked rotor balls, cast rotor bars with large internal voids, broken bar to short circuit ring connections, cracked short circuit rings, like that. Different aspects we can able to identify. So this also sir explained about this 1 minus 2s. So band gaps, side bands. So you can see with the effects that able to get that. So these side bands they are typically 100 to 1000 times smaller than the main power frequency current. In that way we can, that also sir has shown that. Typical spectrum referred from William T. Thompson, and that references I have taken this. So different problems, how it is occurs, broken joints, rotor core pressure supports. So where these are caused by thermal and mechanical stresses. These are even there when there is a thermal expansion of cage. So staked bars fracturing aspect. I think these also shown some. If you could observe cracked broken end rings. Some references I have took this. All these are some of the references I taken. So you can see void. So this will affects the particular pattern, particular signature you will be going to get with these type of problems. So broken rotor bars. So absence of airflow through the ducts during sequential starts. So these broken rotor bars. You can see crack in cage end ring. These are all some of the references I took. So these also some references, Williams. So in that way we can use that, they were using this current signature analysis for this. So this is my overall view of perspective of this. Thank you one and all. So I think we can go for the lab visit. Is a digital manufacturing and automation center. There we can see different labs. I think a test and optimization lab is there. That also may be useful. And also electrical aspects, different drives, they're starting, different type of aspects, applications also we are having other labs, energy saving labs like that also. So the smart factory also there, we can visit that.